Right, this is interesting. So what I've done is I've reconfigured the software. First of all, I've added in the calculation to give us a cell voltage, right? And the second thing is I've actually gone round the circuit and checked. There's obviously the diode, my kind of diode circuits, they're out now. So I put the actual voltage, the voltages across the circuits in now, which is now 3.64, as you can see there, and the other one with the blue diodes is now 6.73. I've been around it, right? Also, the potential divider circuit is accurate, right? And I'm trying to do everything to 3 significant figures because it's a 10-bit ADC, okay, which will give us 3 significant figures essentially. Right, so that is also out, right? Because because obviously it must be a difference between the 2 resistors, and so I put that in as well, which is there. So 2.01 to give us a correct calibration there. Okay, it's not much obviously, but it's there. But also I noticed that it's still reading low, and so I checked the voltage right here on the actual ADC 0, which is the one that's reading directly from the cell, right? And it's reading here 3.74, but I saw the reading in there. Let me go back. Okay, because I've actually restarted the software, so I can't show you that. But if I do this, so the actual reading that I was seeing here was 3.46. So I thought, well, there's obviously an ADC read error, right? And so I calculated that 1.08 to 3 figures. So I put that in as well. Now we have 3.74 on the first cell, 4 volts almost exactly, which is, I'm guessing that's what the actual cell voltage is now. And then this one's 3.4 something, 4.8, right now. And also the pack voltage now is showing at 11.22, because that's where I saw it's out. It's saying 10 point something, and so now it's saying 11.22, which is the voltage. And I believe even if I put the meter on it, the meter will actually say 10.22. Let me check. Yeah. Well, 2.3. Yeah. So that's reading that. So we're actually quite accurate right now. Let's check. Okay. Look at that. Where's that there? Bob on. 4.02. 4.0. And we'll measure this one as well. What we got? 3.5. Ooh. So it shows, yes, you can do it. And it's stable as well. Because that's flicking around, look. That's now 3. Yeah. So it just shows that there is actually a stability and an accuracy to be had. Right? By accounting for and measuring and accounting for the problems in the circuit, you can actually get to the point where, in actual fact, that's showing reasonable accuracy. Alright, let's get that onto there. 2.4. Yeah, look, 11.24, it's right. Huh? Bob on. And that one actually is reading the pack voltage. It's not calculated, that's actually reading it. It calculates the voltage next to it, which is the cell voltage. Right. Very good. Yeah, there's obviously a disparity. So now it's going into constant current mode because I set it at 11. That was a good guess, wasn't it? Look at that. So that cell voltage is pretty much 4 volts, which is what I need. I don't want anything to be above 4 volts. So now it's going into constant voltage mode. It's still providing an amp, so it's still charging, because that's what the one is. Put that. Try and put that there. That's it, so it can. Bugger. I'll tell you what. Do it this way instead. There we go. So it's in constant voltage mode, which means that current will start dropping, right? Yeah. Now we don't have a measure of the current. Obviously the current's there, but we don't have a measure of the input current, which I could actually put an inline current sensor in there. They're not very accurate though. That's the problem. I'm quite pleased. Look at that. 11.26. Yeah, that's right. And I believe the meter more than this even. Because that job, the meter's sole purpose is to meter things, whereas that's just, something that you put on it just to give you an idea of the voltage, I guess. But its sole purpose, its sole reason for existing is to meter things, isn't it? Oh, yeah, 11.26. Yes. There's obviously a bit of noise. Yeah. Yes. Not bad, Graham. And we're not drawing too much current from the battery at all. No. This one is detecting it directly. So this is drawing microamps. Like as in single figures microamps. In order to detect voltage. This is using two 10k resistors. Right, so that's 20k in line with the cell. So that's in the microamps range. Might be in the region of sort of like, I don't know. Off the top of my head, I'm guessing in the region of, 40 microamps. Would be my guess. And this one's the same. It's drawing through a single one. Right? So I might be talking more, like 80. Not even 100 microamps. Eh? I don't think that's actually 40. I think the calculation I've got wrong. But it doesn't matter. You're talking microamps. You're not even talking a milliamp there. No. Obviously the LEDs are lighting, but they don't obviously require much current. No. Wow. That's, yeah. So it shows we can calibrate it. What I'd like you to do is have some mechanism to self-calibrate. Also, I was thinking about, I was doing some research, Gemini basically, AI research, and it was suggesting for me to use a calibrated voltage source, which I actually know does exist. You get there's a variable voltage regulator which you can get, LM32 something or other, and that will give you a voltage a calibrated voltage. It's 1.25 volts. That's how it works. It operates by using a calibrated voltage, and so you can use that in other circuits because you know what it is. It's exactly 1.25 volts, and it's calibrated. It's compensating for temperature and all the rest of the stuff. Yeah, because that's why people buy it. But I don't know how much current it's going to take. It's an inline device. You can just put it in line like a Zener diode, I believe. Don't think it needs a ground, not to operate, but it probably draws a considerable amount of current. But I'm going to find out anyway. But that's good.